Okay, for free response question 3, the most important part of this problem is being able to read and interpret the situation. So we're going to read through this, and I'm going to highlight the key pieces of info we need to pick out. So they say the lighthouse is in the ocean 50 feet away from the shore. The light spins around, completing 15 rotations every minute. At t equals 0, point P is in the center of the light, is pointing directly away from the shore, 200 feet away from the lighthouse. The distance from the shore periodically increases and decreases as the light rotates. The second part will be more or less the same every single time. Only difference is sometimes the letter right there will change, but doesn't really matter. First thing we're going to do is label our points. So each point we're going to have a t and a d of t, an x and a y, whatever they call it for that problem. Usually this is t and some function of t. So the first thing I'm going to start with here is our vertical, our y coordinates. So there's a couple different things they can give us. They can give us a minimum, a maximum, a radius or an amplitude, and a midpoint. In this case, we're given 50 feet away from shore is where the lighthouse is. So that is our midpoint. So we can fill in 50 here and here. And we know that because the point is rotating around the lighthouse. That lighthouse in the middle of it. Next, they say the center of the light is 200 feet away from the lighthouse. So that means our amplitude is 200, because from here to the point, or here to here, is 200. So if our amplitude is 200 and our midpoint is 50, we are going to get all the way up to 250, that is 200 plus 50, and all the way down to negative 150, to 50 minus 200. As it says here, a negative value of r of t is behind the lighthouse on the same side of the shore. So the negative means it's 150 feet towards the lighthouse, or onto the shore. This image is not totally to scale, as it says down there. So getting the y coordinates here is worth 1 point. That's usually a little bit easier than getting the x coordinates. So for the x coordinates or the t coordinates, they're always going to give you a starting point. So they're going to say at t equals something. So like right here, they say t equals 0. The light is directly away from the shore, which is where they show up there. So t equals 0, it is as far away from the shore as it's ever going to get. That would be either at F or at P. I'm going to pick F because then we have positive numbers and it makes the rest of the problem a lot easier. The next thing we always want to get is we want to find our period. So they're going to give us something about the speed at which this is rotating. So this completes 15 rotations every minute. Because this is rotations per minute, that is our frequency. If it was minutes per rotation, that would be the period, how long it takes to do a cycle. So since we're given frequency, to get period, all we have to do is 1 over frequency. So our frequency is 15 rotations per minute. Our period is 1/15 minutes per rotation. Not that the units really matter here. Once we have our period, we know this other side, when we get back from a max to a max. That's going to be 1 full period later, so 1/15. To find the other points, you can do a couple of different things. I think the easiest way is to find our spacing, which is which is the period over 4. So that is 1/15 over 4, which is 1/15 times 4. If you divide a fraction by a number that multiplies the bottom, is 1/60. So once we have our spacing, we can just add that on. So f is at 0 plus 1/60 is 1/60. J, add another 1/60, that could be 2/60. For the AP test, they are totally fine if you do not simplify your answers for this problem, for the no calculator section. For now, I'm going to leave them unsimplified, and then I'll go through and simplify them at the end. So we have 1/60, 2/60, next is 3/60, and then our last one could be 4/60, which simplifies to 1/15. So each section here, instead of 3/60, you can divide the top and bottom by 3, we get 1/20. Next one, instead of 2/60, we could make that 1/30. 1/60 is already fully simplified. If you're not comfortable simplifying fractions, you don't need to worry about that. They will take the unsimplified versions. Okay, once we've gotten part A done, part B is always going to say find the equation. The only bit that changes here is whether this is sine or cosine. So I would always start with A and D. A and D are worth 1 point, so are B and C. A is our amplitude. That is the height from the middle to the max. From here to here, that was up 200. We got that from the problem. A is 200. D is our midline. That's pretty clearly 50. Getting that from our graph up here. Okay, next up we have our B, and the way to remember this, 2 pi is the normal period for sine or cosine, and we divide by B because that is the horizontal dilation by 1/b, just how it transforms any function. So 2 pi over B, you can also just remember that. Our B, I totally messed that up, sorry. 2 pi over the period. I'm not going back to re-record, it's too far into this video. 2 pi over the period. Our period here we found is 1/15. So that's 2 pi over 1/15. If you keep, change, flip, so keep the top, change to multiply, flip to 15/1, we get 30 pi is my B. Lastly, our C, that is just a starting point. So because this is sine, I'm gonna make that all green. Because that is sine, we just need to pick a point in the middle going up. So K is in the middle going up. Our C could be 1/20, but because it is C, you always have to flip the sign and make it negative. And I'll highlight that just so it's easy to see where this came from. If this was cosine, instead of picking K, you could pick either P or F, because those are at the top going down, which is where cosine started. Okay, almost done with this. Part C. they're saying between K and P are what we're looking at. So I'm going to look between point K and point P and look what is true about the graph. So from K to P, the first thing is saying is H positive or negative. So to check if it's positive or negative, we are just going to look at the y coordinates. So my y coordinate is 250 and 50. Both of those are positive numbers, so it is for sure positive. We can rule out C or D. Increasing or decreasing, that just means, are we going up or going down? From K to P, we are very clearly going up, so this is positive and increasing. Last question, part C2. From T1 to T2, that's the same K to P. Describe the concavity of H and determine whether the rate of change is increasing or decreasing. Sometimes this question will ask you about concavity. Sometimes it will just say, describe how the rate of change is changing. Only put what they ask for. If you put extra info, if it's right, there's no problem. But if it's wrong, you lose the entire point. So only put what they ask for. From K to P, our graph is increasing, which means the rate of change is positive, but they don't ask anything about that here. The concavity, if we draw that line on the graph, that's concave down. So I would start by saying on the interval T1 to T2, H is concave down, and the rate of change is, we're going to say either increasing or decreasing. Because this is concave down, that means the same thing as the rate of change is decreasing. If you said something here about the rate of change being positive and decreasing, you would still get the point. But if you said negative and decreasing, even if you had exactly what I had here and you said the rate of change is decreasing and negative, the entire thing would be wrong because you put one wrong thing in your answer. So only write down what they ask for. So they asked for concavity and whether the rate of change is increasing or decreasing. So I have the rate of change is decreasing and H is concave down. No more than that.